After checking the machine and tools, and setting up the correct spindle speed and tool, machining can begin. To move the tool along the Z-axis, which is parallel to the bed, the carriage handwheel is rotated. Rotating it counterclockwise moves the tool towards the chuck, while rotating it clockwise moves the tool away from the chuck. The tool can also be moved along the Z-axis when using the compound slide handwheel. Rotating it clockwise or counterclockwise moves the tool towards or away from the chuck, respectively. To move the tool along the X-axis, which is across the chuck, the cross-slide handwheel is rotated. Rotating it clockwise will move the tool towards the chuck center, while rotating it counterclockwise will move the tool away from the chuck center. These two tool movements will dictate the depth of cut and feed direction for machining operations. During a facing operation, the depth of cut is controlled by the carriage or compound slide, while the feed is controlled by the cross slide. During a turning operation, the depth of cut is controlled by the cross slide, while the feed is controlled by the carriage or the compound slide. Some operations require a datum, also called a 0 point or reference point, to be set. Setting a datum allows the use of the handwheel dials to keep track of the tool movements. When setting a datum, the tool is moved to the workpiece surface, and the dial is rotated to the 0 mark. This can be done on the carriage handwheel and compound slide handwheel to set the 0 point along the Z-axis, and on the cross slide handwheel to set the 0 point along the X-axis. After the datums are set, the tool movement can be measured by reading the dials, as the handwheels are rotated. However, most conventional machines have an inherent mechanical problem called backlash or play. Backlash is the loss of movement due to the clearance or gaps between moving parts, such as a lead screw and a nut. This results in the carriage, compound slide and cross slide to move inaccurately when their respective handwheels are rotated in the reverse direction. Let's take a look at the inner workings of the cross slide when its handwheel is rotated. The handwheel is attached to a lead screw. A nut, which is threaded into the lead screw and attached to the cross slide, moves forward as the handwheel is rotated clockwise. The nut moves back when the handwheel is rotated counterclockwise. This is how it would look if the lead screw, nut, and cross slide were sectioned. In a perfect system, the nut moves the exact amount as the handwheel is rotated. For example, if each round of the handwheel moves the nut by 6 mm, then 10 clockwise rotations of the handwheel would move the nut and the cross slide by 60 mm. And, when the handwheel is then rotated 10 counter-clockwise rotations, the nut and the cross slide would move by 60 mm and return to the initial point. However, in an actual machine, all moving parts have clearance to prevent jamming, and at times the clearance gets larger due to wear and tear. Therefore, there's a small gap between the threads of the lead screw and the nut. This causes backlash. As before, when the handwheel is rotated clockwise, the nut moves forward. The nut moves to the 60 mm mark when the handwheel is rotated 10 times. After stopping, the handwheel is immediately reversed. Notice how the nut does not move, although the lead screw is turning. The nut and the cross slide only starts moving when the lead screw touches the opposite sides of the thread. When the handwheel is rotated 10 counter-clockwise rotations, the nut and the cross slide does not move by 60 mm and return to the initial point. Although the handwheel shows 0, the nut is not at the 0 mark. Thus, backlash causes measurement errors when using the handwheel dial to measure and track tool movement. Therefore, The rule to negate backlash is to measure only in one direction. This means, when measuring the movement of the cross slide, do so in only one direction. For example, if the cross slide was to be moved to the 60 mm mark, but had accidentally overshot the mark, do not simply move it back to the 60 mm mark. Although the handwheel dial shows the correct dimension, the cross slide is not at the accurate position. To correct such error, reverse the handwheel multiple times to move the cross slide well before the 60 mm mark. Then, rotate the handwheel in the same direction as before to move the cross slide to its necessary position. This ensures that the measurement shown on the handwheel dial correlates to the cross slide's position. The technique you saw used on the cross slide is also used on the carriage and compound slide. Always remember, to negate backlash, move the tool in one direction when measuring. During machining operations, chips, also called swarf, will be created as the material is cut. These chips must be removed to prevent damage to the tool or workpiece and to maintain operator safety. If the chips are not removed, nesting can occur. Always stop the machine and use a pair of long nose pliers to pull the chips away. After clearing the chips, machining operations can resume. Never use your fingers to remove the chips, as they are sharp and hot. Do not use a brush or remove the chips while the workpiece is rotating, as this is dangerous due to entanglement hazards. After machining is completed, remove the workpiece and tools. To clean up the machine, use the provided brushes and dustpan to brush the chips into the chip pan. Clear chips that are stuck in the corners and grooves of the machine. Use a small brush to clear chips in the chuck. Brush the chips off the splash guard. And move the tailstock to access and clean the bed too. If necessary, move the carriage to access all parts of the lathe machine when cleaning. Pull out the chip pan to consolidate the chips and brush out the chips onto a dustpan. Dispose the chips into the appropriate waste bins. Use a broom and a dustpan to sweep chips off the floor too. Clean the tools before storing them. A wire brush is used to clean the file. Return all tools to their respective locations and hang the signage onto the safety guard. Finally, power off the machine. The demonstrations you saw are the typical processes to be adhered to when operating the lathe machine. Using the tools and machine as intended will prolong their life and allow you to produce accurate parts safely. Speak to an SP staff if you require assistance during any machining operations.